functions, and we will be using these two formulas because it's about compound interest and continuous compounding. So in the course of the lesson, we will differentiate between these two. So this is the formula for compound interest, and this is the formula for continuously compounding. So this is the first problem. Okay, the trick here is to differentiate between the two, whether you're dealing with a compound interest or continuously compounding. And you can actually see it from the problem itself. It says here, compounded continuously. So we will have to use that formula for this matter. So Natalie invested 1,200 in an account. So the principal is 1,200. Now this principal is earning 6.4% continuously compounded. So the rate is 6.4%. And we should change this into a decimal because that won't work when it comes to finding the values in our calculator. So by either moving the decimal point 2 places to the left side or dividing this number by 100. Okay, so this will be 0.064. And you're asked to understand the problem to the nearest dollar means that we need to round off our answer to the nearest whole number. And our time is 17 years. And we are trying to find the future value, which is A. Because it is continuously compounding, this will be the formula that we will be using. And our A is supposed to be missing. So we will solve it. So our P is 1,200. E raised to 0.064 times the time, which is 17. So what we do is use calculator to help us calculate our value, and that's 1,200. And then second ln, that's where you can find the value of E, 0.064 times 17. And it gives us 3,561.99, but we want it to the nearest dollar, so it's going to be $3,562. So after some time earning this interest, that would be the amount of the investment. Interest, because it says here compounded quarterly. So Blake is going to invest in an account paying an interest rate of 1.5%. So our R is 1.5. Then of course, we will change it to decimal by moving the decimal point 2 places to the left side. Now, how much would Blake need to invest? So it means that we're trying to find the principal instead to the nearest dollar for the value of the account to reach 910 in 10 years. So it means that our future value is 910 and our time is 10. Of course, we will try to find the P. Okay, since it is a compound interest, our compound interest formula is equivalent to A times P, 1 plus R over N times NT. Okay, N representing the term of interest per year. And it says here compounded quarterly, so our N here will be equivalent to 4. And so we will need to plug in our values in our formula. So our A is 910 is equal to P, which is not here. It's still yet to come. So 1 plus 0.015 divided by 4 raised to 14, which is equivalent to 10. Then of course we can simplify this value to make our life easy. Just get this value and maybe round it off for like about 4 decimals to be more accurate. And so we have this value and simplify it. So that's 1 plus 0.015 divided by, you can use alpha y equals, it's the same. Okay, raised to 40, which is 4 times 10. And then you will have this value, 1.615. So we will use 1.615. So 910 is equal to 1.6, let's be sure, 1.1615, okay, times P. Okay, and so we don't actually need any sophistication in our solution because All we need to do is to divide the whole equation by 1.615 because our purpose is to isolate P. So therefore, our answer will be 910 divided by that value. We can always just go up there and then enter and then enter. It's about $783 because it asks us to give our value in the nearest dollar. So P is $783. So it means that we need to invest this amount for our investment to become 910 after 10 years in the rate 1.5%. Paying an interest rate of 2.1%. So our rate is 2.1%. And of course, this is the same as 0.021 in decimal. And our investment, which is our principal, is $280. Assuming no deposits or withdrawals are made, this is a compound continuously. How long would it take to the nearest tenth of a year? So this time it's the first decimal to be rounded off for the value of the account to reach 360. So our future value is $360. And we're trying to find the time. Time is unknown here. Okay? Because it is continuously compounding, this will be our formula. Okay, all we need to do is to substitute the information to our formula, and that's 360 is equal to P, which is 280, E raised to RT, which is 0.021 raised to T. Okay, and then of course, we've learned from our previous lesson to solve this is to isolate the T term. So we have to divide by 280 on both sides of the equation. And so, what happens here is that we have 360 divided by 280 is equal to E raised to 0.021t. And then all we need to do is to take the natural logarithm of both sides of the equation. We can do the shortcut already since we already have known that we are applying the power rule right after. And we also know that the value of ln E is equal to 1, so we can just cancel it. And so we just need to divide each side of the equation by 0.021. Now, I'm not expanding this anymore because we're not concerned about the exact value. Actually, this is the exact value, and so we don't need to expand 360 divided by 280. All we need to do is to use our calculator to solve for our value t. And so you'll have here alpha y equals, enter, because I have your ln, and then I'll go again and use the alpha y equals to put 360 divided by 280. Okay, and then of course we will divide by 0.021. And the time is 11.96 years, but it asks us to the nearest tenth of a year. And if we're going to round up 6 to 9, it's going to be 1 here, 0 here. So this will be like approximately 12 years. So T is equivalent to 12 years. Now, of course, this will be the long method to do this, but if you know your equation, you can always use your Desmos graphing calculator to do it for you too. So all you just need to do is to put the equations on both sides, put them in the y form. Our first value is 360, y equals 360, and our second value is 280. E, just write E. It will accept it. Raised to 0.021t. Use x for t. And of course, you will have to find the graph for your equation and zoom your Desmos, and it's here, and as you can see is the same as what we have obtained in our problem. Use a calculator to solve it instead. Gianna is going to invest $9,000, so our P is 9,000. And the time it will take it to reach this certain amount 23,300 is like 17 years. And we're trying to find the rate of interest for this investment. And our final amount or future value is 23,300. Okay, since it is a compound interest daily, our term of interest is 365 in a year. So we will use this formula because as it was stated in the problem, it is compounded daily, making it a compound interest problem. So our A is 23,300 and our P is 9,000. So 1 plus our R is unknown over 365 raised to 365 times 17. Now, when we're using calculator, it's best to reduce our equation because right here, you can actually reduce 23,300 and 9,000 to just 233 and 90. 1 plus R over 365 raised to 365 times 17. So if we are using our Desmos graphing calculator, so this will be our problem. Just write y equals 233 on our first path and y equals 90 plus x over 365 raised to 365 over 17. Okay, and then of course, originally your graph looks like this. It doesn't show much, but if you're going to zoom it, you would see the point of intersection right out, and it gives you 0.056. So R is 0.056. But of course, you need to analyze clearly your problem. It says here, to the nearest tenth of a percent. Before we can do that, we need to change this into a percent form by moving the decimal point 2 places to the right side, which is 5.6%. Now, you can also use multiplication by 100 to reach this number. And of course, this is already tenth of a percent. That entails a known amount of investments. So an investment is made for a company that earns 5.5% interest rate per annum. So our rate is 5.5. And then of course, this becomes 0.55 in decimal. And it is compounded semi-annually, so therefore our term of interest is 2 in a year or twice in a year. And then you're asked to find how many years will it take for the money to double. So you can use any amount here. It's going to be the same. I'm going to prove it to you later on. So let's say I'm going to make use of our future value to be 20. Therefore, my principal is 10. So as you can see, if I'm going to cancel 0, actually I'm using 2 and 1. I'm just showing it to you that the amount will double in such time as long as your rate of interest is not changing. So this should supposed to be constant. For all the values that you're thinking of will be the same to double in a particular time. So this is a compound interest. So we'll use A equals P 1 plus R over N raised to NT. So our A is 20 and our P is 10. 1 plus 0.055 over 2 raised to 2t. Okay, now we just use the Desmos graphing calculator. Anyway, we already have proven that we can solve it algebraically, and we can also solve it using our calculator. Just make sure that you're equating always your both sides of the equation to y equals 20. It is important because you see, if I'm not going to make use of y equals, I won't be able to see any graph. So I need to make an equation in order to see a graph. So the other equation is y equals 10, 1 plus 0.055 divided by 2, and then our exponent is 2x. And as you can see, you have the point of intersection, which is t equals 12.775 years. Now, I told you, it won't matter what amount you will use as long as the principal is doubling. For example, if I'm going to use 4,000. This 4,000 should become 8,000 in about 13 years. So I'll use 4,000 using the same term of interest. I can just copy this. And then our exponent is 2 times 12.775. And as you can see, the money is 8,000 after some time, which is after 12.775 years.